All right, so I encourage you to have a watch, but if you want to continue with what you're doing, you're very welcome to. I had a few people ask me this question. So this is 2G. We will start with question 6, and if we have time as well, we'll address 7. Now we're told the function is a ln of 2x plus b, and we're told f of e equals 3. So when x is equal to e, that's 2.7, the y value is 3. And when x is equal to e, the slope is 6 on top of e. So we've done a few of these questions before. We've got two unknowns. We've got a and b. And what we need to do is just try and get as many marks as possible, all right? And we're going to do that first by using the information that we're presented with. So the first piece of information we've got is when x is e, the y value is 3. So I'm going to put 3 here. Or maybe, let's even try and make the argument a bit more cleaner. I'll say when x equals e, y equals 3. And so I'm going to plug that into our equation. So we'll have 3 equals a ln of 2e plus b. Alright, that's the first piece of information there. And we'll just leave that as it is for now, okay? We can see it can be rearranged to get a by itself, but we'll just leave it for now. And we're going to always look for ways of synthesizing them a little bit later on. Next, we need to use this piece of information, f dash of e equals 6 on e. And in order to use that, I need to know what the derivative function is. So I've got, this is f of x, so I need to differentiate it. So firstly, when I differentiate a log function, so ln of f of x, maybe I'll write the rule up quickly, ln of f of x goes to f dash of x on top of f of x. Okay, that's the rule we're going to use. Now we've got this a out the front. The a is just going to hang out there because it's a times the function. So that's going to stay there. And the derivative of 2x plus b will just be 2. So 2 goes at the top. And then we have the 2x plus b at the bottom. So far we've got 1, maybe 2 marks. We've got a mark here for putting in the first piece of information. We've found the derivative. Now let's use the second piece of information, which is when we put e in, it's going to equal 6 on top of e. So I'll put the 6 on e here, and we'll have 2a on top of 2e plus b here. Okay, so we're looking for some way to bring them together or to bring them down to one variable. So what we'll do, let's start over here and we'll just rearrange to get a by itself. Okay, and now that I've got a by itself, I'm going to take this for a and plug it in here. Alright, so I've got a by itself over here. I'm going to plug that from our first equation into the second one. And so one way you can communicate it is like this can be equation 1, this can be equation 2, and you'll say something like putting or substituting 1 into 2. Okay, so what we'll have if I do that, I'll have 6 on e on the left hand side, and on the right hand side I'll have 2 multiplied by 3 on top of the ln here. All on top of 2e plus b. All right, what I will do in the next step, so we've got one equation now, and you can see we're on the right track because we've broken it down to one variable. We've only got b here. And so it's a mess of an equation, but we're going to try and solve this for b. So we're going to break it down, get rid of the fractions, get rid of the ln's, and see if we can bring them together and so forth. So the first thing I'm going to do is cross multiply the denominators. Alright, so I'm going to multiply both sides by 2e plus b. Alright, so what we'll have over here, we'll have 6 times 2e plus b on the left, and on the right we'll have 2e multiplied by this here. Alright, now we can simplify both sides. I'm looking at this, I'm going 3 times 2 is the same as 6, and I've got 6 on this side as well. So we can get rid of the 6. So we'll do that in the next step. So we'll have 2e plus b, and over here we'll have e on top of ln of 2e plus b. All right. Then we will cross multiply again. So I'm going to move this term up onto this side. So we'll have ln of 2e plus b and multiplied by 2e plus b. I might put it out front. I'll make it neater as well. So we'll have 2e plus b. So that's already there, and I'm moving this denominator up to be a product of it, ln of 2e plus b. And that's equal to e. Alright? So, one thing we can do here, I think we're missing an e somewhere, by the way. I'm just trying to remember this question.
That looks right.
Alright, I'll keep going anyway, and if we've got an error, it'll pop up in a sec. So what I'm going to do, I'm going to move this power, alright, up the top here. So remember when we have a number times a logarithm, that can become the power of the logarithm. So I have ln of 2e plus b to the power of 2e plus b, and that's equal to e. Alright, now e by itself, has a power of 1 on it, doesn't it? E by itself has a power of 1. Now we're trying to get b by itself. I remember. Alright, so I remember, alright, we got it. What we're going to do here is we want to get rid of this logarithm because we're trying to break it down. We're trying to get b by itself, right? So how do we get rid of a logarithm? We raise e to the power of both sides. Alright, so if we're looking at this, we're going to go e to the power of ln of 2e plus b to the power of 2e plus b. Alright, so I'm just taking that whole side and raising e to the power of that whole side. And I have to do the same over here, e to the power of e. And that might seem like a bit silly, but remember, e is just a number. It's 2.7, right? So we have 2.7 to the power of 2.7. Okay, now that we've done this though, e to the ln of x simplifies to x. That's the rule. So if I have e to the ln x, it will simplify to x. I have e to the ln of 2e plus b. So the e and the ln, they effectively cancel, right? So we're going to have 2e plus b to the power of 2e plus b equals e to the power of e. Okay, now we're just going to use a little bit of intuition. For this relationship to maintain, for it to be equal, the base has to equal the base, and the power has to equal the power. And notice they're the same. What's the relationship we have there? 2e plus b equals e. Alright, if the bases are the same, 2e plus b equals e. If the powers are the same, 2e plus b equals e. And it has to maintain in order for the equality to maintain. The base has to be the same as the base, the power has to be the same as the power. And if we solve this for b, we'll subtract 2e from both sides, and we'll get b is equal to minus e. So we have the value of b, alright, and that's quite tricky to arrive at. I'll talk over that again in a moment. But let's get the value of a first, and we're just going to use this equation here. Remember, a is equal to 3 on top of ln of this. So we're going to put that value of b in here for a. Alright, and 2e take away e just gives you 1 lot of e. And ln of e to the power of 1 just simplifies to 1. So the value of a is 3. Alright, so we've got the value of b and we've got the value of a. That satisfies this. So maybe I can just take you through the tricky part again. Okay, what are we doing in a question like this? We're just trying to maximise the amount of marks that we can get, right? So I expect us to be able to do step 1, I expect us to be able to do step 2, we've got that information, and then we need to bring them together somehow. So what did I do? I've taken A here and plugged it in, all right? And then in this step, I've just got B, and so I'm trying to break this equation down to get B by itself. So I cross multiply the denominators, this is what I'm left with. I've cancelled 6 from both sides, and then I've cross multiplied the denominators again, and came up to here. And then I said that number out front, that can be a power. So I've taken that as a power. I've raised e to the power of both sides so we can get rid of the logarithm because we're trying to solve for b. So we got rid of the logarithm and then we're equating the bases, equating the powers to maintain equality. We get our value of b, we plug it back in to get our value of a. Alright, it's a tricky problem. Questions about that one in particular? So I think the next one's a little bit shorter. We'll see. So we got time. I'll have a crack at it. So in this question, we have ax ln of x plus b. Yes, yeah. So you can expect one complex higher order thinking problem like this. Yep. So like this one, like I'm thinking of 2C.2, question 5, question 6 there. So those kind of things. And if you look at the practice tests, we've got heaps of practice tests, right? If you look at them, you'll see which ones we tend to ask and what does pop up. Yeah. So yeah, you can expect there will be some, and that's why I'm saying you've got to try and just maximise the amount of marks you're going to get. And in fact, these questions, I've got a whole worksheet with about 7 or 8 questions of this on it, and I'll bring that to class tomorrow so that you can practice this skill in particular, if that's one where you want to localise your attention. Okay, so here we go. We've got 5 minutes, I can do it. We've got ax ln x plus b. We've got f of 1 equals half ln 3. And we've got f dash of 0 is half ln 2. Alright. So, when we've got 2 unknowns we need to find, we need to use the information that we're given. So firstly, when x is 1, y is half ln 3. So half ln 3 equals a ln of 1 plus b. Okay, that's our first equation. Alright, now we can't we can't straight away assume, oh, a has to be half and b has to be 2. We need to demonstrate that it's true. Alright, we'll find the derivative using the product rule. Smash that together for the derivative. U dash of b plus u d dash. Okay, that's our derivative function. Let's plug in the information here to use that one. So I'm going to put half ln 2. And when we put 0 in, we'll have a ln b. And that part's going to be 0 because we have a times 0. 0 divided by anything can be 0. So we've got a ln b. So we have 2 equations here. We've got a ln b, and here we've got a ln of 1 plus b. So once we've got the 2 equations, we're probably sort of 3 out of 5 marks. We need to synthesize them together somehow. So let's do for a. Right, let's write the 2 equations up here. Let's see if we can describe a way to think about which one I should substitute where. So we've got a is, half ln 3 is a ln of 1 plus b. That's our first equation. And our second equation is half ln 2 is a ln b. Alright. So, either way,
Mr. Ross, the second equation, a ln b, 1/2 ln2. A would be 1/2, B would be 2.
Yeah, I don't know if we can assume that from there, because I think that's the answer we end up with, but I don't think we can assume it because there are other possible values. Like, all of this means is it's the logarithm of the square root of 2. All right, and so it could be that A is 1 and B is the square root of 2. That's another solution, which wouldn't correspond with the one you're pointing at. So that means we do need to bring them together somehow. All right, so let's just have a go. I can't see an easy way around it. We're just going to have to do a bit of trial and error. So let's start with equation 2, and I'm going to make that A equals half ln2 on top of ln B. All right, so that's my value for A. I'm going to put 2 into 1. So we have half ln3 equals half ln2, half ln of 1 plus B. That's not half. Half ln3 equals half ln2 of 1 plus B. And that's on top of ln3, isn't it? Okay, that's A. That's our value of A. So I'll plug that there, ln of 1 plus B. Okay, so I've got half on both sides, so I can cancel that. So we've got ln3 equals ln of 2 on ln of B multiplied by ln of 1 plus B. Got rid of the half. Now I'll cross multiply the ln B, so I have ln B ln3 equals ln2 times ln of 1 plus B. And so this is how we can determine the value for B. We'll have ln of B to the power of ln of 3, and over here ln of 2 to the power of ln of 1 plus B. And so these logarithms are going to be equal to one another. We've got B equals 2, all right? And up here we've got 3 equals 1 plus B. And so that gives us the value of B